Alright, so in what will be my last round of videos on correlation, I wanted to illustrate a few points on how correlational design can actually be a little bit more complex or advanced than you might initially suspect. So it seems like correlation is so basic that it could only really be done in simple self-report surveys at a single administration, and it can only involve two variables. Actually, there's ways to make your correlational design and analysis a little bit more advanced to ask slightly more interesting questions. So first I want to make sure to walk you through the various ways that you would interrogate the validity of your correlational derived association claims. So this is basically all of the ways that you need to think through whether you have met the bar for various validity types, meaning that the claims you make from your correlational research are legitimate and well supported. One, you need to be careful to evaluate your construct validity. So essentially making sure that you're thinking about how well each variable was measured. So this is a process you guys have really already been through. When you were creating your survey materials, essentially you were interested in the variables you named, and I would push you guys to think about, well, how are you actually measuring that? What's a way that you can actually ask questions that get at that construct you're interested in? So this is something that you really need to do in advance of your correlational research. Just ask yourself whether or not the tools and measurement approaches you're using are really solid and associated with those constructs you're interested in. You still need to subject your correlational research to statistical validity. So you basically need to evaluate things like whether or not you've had a sufficient sample size and whether or not your correlation has achieved significance. We've already talked about that. So then moving on to internal versus external validity. So these are two bits of validity where we're gonna kind of go beyond the basic correlational research claims and think about how these kinds of validity do/do not apply when we make correlational or association claims. So internal validity is a concept that we talk about particularly when we're designing research studies where we evaluate how well our analyses enabled us to rule out other possible explanations or confounds, meaning did we rule out potentially impactful third variables that might have been impacting the research effects that we find. This is really where correlational research actually fails. In order to make a causal claim, internal validity bars do need to be met because the idea is if you want to claim that one variable causes changes to another, you can't just correlate them together. You need to rule out external confounds that might be impacting both of your first two variables. So internal validity is really why correlational research really fails to help us make causal claims because at the end of the day, it's damn near impossible for correlational research to enable us to rule out possible confounds. But correlational research does provide a great place to start for trying to figure out future directions to look for causality because it can help us establish some of the criteria for making a causal claim. So the three criteria that help one make a causal claim that come about from your more rigorous experimental paradigms is going to be covariance. So do the variables change together? Right? Correlation can obviously do that. Temporal precedence. So variables that are causing changes to other variables need to be identified as occurring first in time. They precede the variable that is being impacted, and then you're ruling out of third variables. So this failure of internal validity is really the only reason correlational research can't necessarily get us over the hump of being able to make causal claims. Right, so correlational research absolutely can help us preliminarily identify that variables are changing together, which is a necessary criteria for causal claims. This temporal precedence piece, well, not necessarily, but it actually can. Correlational research actually can, depending on the paradigm, help you establish temporal precedence. So in the context of your guys' research, you can't necessarily find which variable occurred first in time because all of the questions participants are answering are just happening in a single survey administration. But there is a way that you can kick your correlational design up a notch to help figure out which variables happen first in time. And I'm going to explain this a little bit more in depth. Now, correlational research definitely cannot help rule out potential third variables, so it does have the lack of internal validity as a problem. But on that note, I am going to talk about an interesting approach to correlational design that we call moderation. This is essentially going to be a way that we can introduce third variables into our correlational analysis to not necessarily rule them out, but to see how they apply. So, in these last two pieces that I'm going to talk about, this temporal precedence bit and moderation, I'm basically going to demonstrate that correlation can sort of get you at least part of the way through all of these criteria for a causal claim. So the first is with what we call longitudinal design. So whenever you're doing a correlational study, where everyone is answering questions at the same time and you have a variety of likely different ages of individuals, that's what we call a cross-sectional study. Essentially, in a cross-sectional study, you can't really do much to determine which variables happen first in time because everyone is being surveyed at the same point in time. The counterpoint to a cross-sectional study is what we call a longitudinal study. The definition of a longitudinal study is just any research, survey, or study that takes place over a long period of time. It could be days, weeks, months, or years. This is obviously a more logistically taxing approach, but there's a good reason to use it if you are interested in getting to this temporal precedence claim. So I'm going to show you an example of a longitudinal research to illustrate this. I know a fair amount of you are interested in bullying, peer-to-peer aggression, so here's an example that references that construct. These researchers were interested in concurrent, cross-sectional, and longitudinal experiences of bullying and their contribution to mental health. So basically, they ran a collection of data over the course of many, many years, where they evaluated bullying at all the various time points and mental health at all the same time points. Essentially, if you were to just sit down and survey a group of children at a school and ask them about the extent to which they're bullied and the extent to which they're suffering from, let's say, anxiety, if you found the kids who were more bullied were more anxious, you couldn't really claim that the relationship was going in any particular direction. Maybe the kids who were bullied were then going to be more susceptible to anxiety because of the bullying. Or it could be the case that kids who are already suffering from anxiety are more likely to be picked on. So the anxiety happens first in time and is more likely to cause bullying to happen. Additionally, you can't rule out an even trickier explanation where maybe some other third factor was impacting both bullying and anxiety. Maybe something like socioeconomic status, where children who are more susceptible to bullying are also more susceptible to anxiety because they come from underprivileged backgrounds. You can't rule out any of those. In a longitudinal study, though, you can at least rule out one of those possibilities. So in this particular research, which took place over many, many years with over 10,000 participants, researchers found that bullying experiences at an earlier time point, in the absence of anxiety at time point 1, was associated with more mental health, anxiety, depression, etc. at a time point 2. So bullying happened first in time and was associated with mental health consequences later in time. So when I say you can rule out at least one of the explanations, this rules out that anxiety causes people to be bullied or being depressed causes people to be bullied. Yes, we are still unable to rule out the third factor problem. We can at least rule out that the direction of the relationship is from mental health to bullying. So that's stronger evidence for bullying causing mental health consequences, even though it doesn't go completely far enough in helping us rule out third variables. So then on to this external validity piece. External validity is essentially the extent to which you've demonstrated that your results that you find in one correlational study or any other kind of study would replicate in other samples with other kinds of people. It's basically the extent to which you think your findings would generalize to other people in future data collection. You get to ask yourself whether or not you are prioritizing external validity, and you can determine to whom you think it is valuable to generalize your research findings to. It obviously is impossible to get perfect external validity all the time because at a certain level, we're stuck surveying people that we are able to distribute our survey to. So a certain aspect of this question is to just ask how important external validity is for your research question and just how badly you've failed to attain your ability to generalize. Another approach is to think about whether or not there's any third variables that impact the correlational effect that you have found. So this is another approach to evaluating external validity. This is essentially when you think there are factors that'll impact your likelihood of finding a result, and you take them into account, and you actually aim to measure them and figure out how that third variable might be impacting the relationship between your first two variables. So this entire concept is going to be what we call moderation. Moderation is a way that multiple variables can be related to one another. A moderating variable is when you have a third variable that impacts, changes, or affects the relationship between two other variables. So we're going to get into moderation, we're going to look at some examples, and I'd like you to think through examples of possible moderating variables with any correlation that you might be studying or interested in. Okay, so this is where you can make your correlational research slightly more interesting, whereas you start simple by framing your research question in terms of how two variables are related to one another. Moderation is going to be where you predict that some other third variable that we'll identify as z impacts the relationship between x and y. So this is when a third variable, in a way, when taken into account, changes the way that underlying correlation looks. It changes the strength or even the direction of that underlying variable. So when we think moderation, this is a process where we're asking about when or for whom there's a correlation between x and y. And we predict that for different kinds of people, the for whom is represented as variable z, is going to impact when you find a certain correlation. So as I mentioned, a moderator is going to be any variable that when taken into account, you see an alteration in the strength or direction of the relationship between two variables. When you have a moderator, you have what's called an interaction. This is when the effect of one variable depends on level of another. There's different kinds of interactions between more elaborate combinations of variables. Moderation is going to be a simple kind of interaction. So a moderator is the variable that's doing the changing. Moderation is the name for the kind of interaction that exists when you have a moderator. So some example questions. What if the effect of social support on depression differs by gender? Basically, this would mean that you need to identify levels of that moderating variable, gender, and think about how it affects that underlying correlation between social support and depression. This could be a basic question of gender differences. Is there a stronger correlation between those two variables in men or in women? Your moderator does not need to be categorical like gender. It can be a quantitative variable like age. You do still have to think about how that moderator breaks down into different levels. When you have a quantitative variable like age, the question becomes, how am I going to break it into different levels? Am I just going to separate people by below 30 and over 30? Am I going to have teenagers, middle-aged adults, and older adults? If you have a quantitative variable like that, it's really up to you how you want to break it down into all of the levels that exist within it. So if we're thinking that there's a moderation and we're wondering for whom a certain correlational relationship exists, you would predict to see different levels of the moderator lead to different outcomes. More strictly speaking, different levels of the moderator lead to different strengths of correlation. So here's a basic example of how you could visualize this. If, for example, you thought that gender moderated the correlation between extroversion and participation in group conversations, a very easy way to do that would be to split your data file into groups where there's different output for men versus women, and run a Pearson's R for those two groups separately. If you find that for women there is a very strong positive correlation and for men there's basically no correlation whatsoever, that would indicate moderation, because depending on level of the gender moderator, you see a different strength of that underlying association. Now make sure when you're thinking about moderation that you're thinking about the three variables present. Okay? This is something that people get confused about a lot. They think that if they're talking about different levels of their first two variables in the correlational analysis, you're talking moderation. No, that's just your Pearson's R. In order to be talking moderation of a correlation, you need to identify your first two variables in the correlation, variables x and y, and then you need to think of a third variable, z. So in this case, variables x and y would be extroversion and participation. Gender is that moderating variable z, because when you break down the data by levels of the moderator, you see the strength of the correlation change. And then there's one last thing I'd like to point out on this slide, where looking into moderation can really make a big difference in terms of the results that you find. So if you were in this hypothetical research here to not take gender into account before running the correlation between extroversion and participation in conversations, you would get a misleading sense of just how those variables were associated. If the men and women's correlation were averaged together, your Pearson's R would be somewhere in between that 0.49 and that 0.07, and you would be led to believe that the correlation between extroversion and participation in conversations was pretty small, weak, potentially not significant. Taking the moderator into account tells an entirely different story that more accurately captures how these variables are related. There's actually a quite strong and significant correlation just for women. For men, that correlation appears to be about 0. So taking into account a moderator can be the difference between finding data that is accurate and data that is misleading. Another way that you can visualize moderation is through line charts that look like this. So what we're seeing here is a moderation whereby the correlation between depression and stress is moderated by social support. Now let me explain. Here on these two axes, we see level of depression here on the y-axis and level of stress here on the x. If we don't take social support into account whatsoever, our results would be kind of the average of these three lines. What we would see is a still pretty strong relationship between depression and stress, whereby even without social support in the equation, depression is associated with more stress. More stress is likely associated with higher levels of depression. What happens when you take social support into account, which as you can see has been split into levels of high, medium, and low. So this thicker bar represents people who have a lot of social support. This thinner bar represents people with very, very low levels of social support. What you see is that the slant of these three lines is different, which indicates that levels of the moderator is associated with different strengths of the correlation between depression and stress. What you can see is that this line representing people with very little social support, they don't have a lot of people in their life who they feel they have strong bonds with, you see that the relationship between depression and stress is at its strongest. If you don't have people to fall back on, stress and depression are very, very highly linked. If you evaluate the line representing people with a lot of social support, basically a lot of people in your life that you can lean on and talk to and you feel close to, you see that the slant of that line representing the correlation between depression and stress is a lot more horizontal looking. It's not slanted as extremely as these low social support people. What that means is for people with high levels of social support, the correlation between depression and stress is weaker. The correlation is not as strong if you have a lot of social support. This would be a type of a moderation that we could call buffering. For people who have high social support, the effect of stress on depression is just a little bit reduced. You have a buffer whereby maybe you have an easier time dealing with stress. So this again is an example of a moderation. You want to make sure that you can identify your first two variables that are correlated, so depression and stress, and that you've identified a third moderating variable that has been broken into groups. Like I said, when you break your moderator into groups, if it's a categorical variable, you just need to use the different levels of the categorical variable. If it's a quantitative variable, you can just split it into high, medium, and low, or just high and low. Critically, when you use a line to depict the strength of the correlation between these two variables, moderation would be indicated by the slope or slant of these different lines being different. So the fact that this line is at a different slant than this top line indicates that social support is moderating the relationship between stress and depression. And again, I know I'm harping on this point. If you're talking about a moderation, make sure that you have a variable x, a variable y, and a variable z, and you're thinking about how all of these things interplay. So I'm going to show you a series of graphics that depict other sorts of moderation. Basically, if you're trying to draw up an example of a hypothetical moderation, again, if you have these different slopes of lines that indicate that the relationship between your first two variables hinges somewhat on a third moderation, on a third variable, there's an indication that you might have a moderation. Again, something like gender moderating the correlation between two variables. In this case, this one shows the correlation between extroversion and Facebook use, whereby for men there's a significant negative correlation and for women there's no correlation. That might be an example of a hypothetical moderation. Something like this, the relationship between age and SAT score, broken down by men versus women. This particular graphic shows you both the scatter plot and the best fit line. And basically you can see that for the men, there's a significant negative correlation between age and SAT. For women, there's no correlation whatsoever, since you can see that line is horizontal. And then lastly, here's one more graphic showing moderation. Basically, again, a chart like this can depict moderation if there's a variable identified here on the x-axis, here on the y-axis, sorry, and down here on the x-axis, and that you have a legend indicating levels of the moderator. Whenever I do something like this, I make like one solid line, one dotted line, and one squiggly line, whatever you think looks cool. Basically, as long as you have an indication that there's different levels of the moderator and that the slope of this line, which indicates the strength of the correlation, is different, you are likely on the path to thinking about a hypothetical moderation. So, to wrap up, if you want to assess moderation, this will be a process of asking whether levels of a third variable might impact the relationship between two other variables. So this is why it's a for whom question. The for whom, is there a relationship? That for whom represents your third variable. So again, something like gender. If you think gender moderates a correlation, the idea is the gender variable is telling you for whom there's a correlation, or for whom there's different strengths of a correlation. There's going to be different ways to analyze moderation. We're not going to do anything fancy this semester. We're not even going to do anything remotely advanced in SPSS. If you're interested in moderation, it can be as easy as splitting your data file between levels of your moderator and just eyeballing the different correlations. If you have reason to think you might have a moderator in your data set, talk to me about it and we can figure out the easiest way to get that data analyzed. So then for your discussion for the week, which is available on Canvas, you can choose to talk about a correlational publication that you found. Basically just find a paper on PsycInfo that has a Pearson's R, or you can think through a moderation. So identifying a correlational design where you make sure that you're identifying two variables, and then identifying a third variable representing your moderator. You're going to want to sketch a visual, so something that looks like any of those visuals I showed you, where you have your X and Y axes depicting your first two variables, and some sort of legend indicating what different types of lines indicate for levels of the moderator. Anything that looks akin to the examples I've shown you should be pretty good to go. And if you want to think a little bit more about this question, think about how you could transform any of your correlational designs into a longitudinal study, just to help sort of get you thinking about how longitudinal research might work. With that, I'm finally done talking about correlations. I hope you guys are doing well, and I'll talk to you soon.